Okay. So here is what you saw yesterday in lab. We're going to kind of go through this together, and you guys are going to help me work through this. So letter A. Letter A. How did it look? Black and dull. So black / dull. Letter B. How did it look?
Shiny.
B was shiny.
That's my favorite.
Shiny, small, silver. Letter C. What did it look like?
Shiny.
Was that the shiny little... Were those little balls or...
No, there's that big piece of like
The black one, the glittery one.
Oh, really shiny. I know. I remember what it is. Very shiny. What was D? Those the little balls?
Yeah.
Yeah. So the shiny, let's say, spheres. E looked like what? What color was it?
Yellow and yellow.
Yellow and dull.
Gray is dull.
Yellow smell like pork.
Actually, I think it was what?
Why were we feeling?
F,
Gray. Actually,
gray, and what else? Gray, dull. It was kind of stringy, right? And G looked like shiny, kind of pokey, right? So, crushing, A. Brittle. So, brittle. What about B? Malleable. I'm going to write M for malleable. C? That broke into pieces. So that was brittle. What about D? Those little spheres. Malleable. You could see when you hit them with the hammer, it kind of flattened them. That was malleable. Okay. E? That was brittle. Broke into pieces. F? Yeah, you could like bend it with your hands, right? So that was definitely malleable. And G, the shiny thing, you could flatten those. That was malleable. Conductivity, yes or no? A. No. B.
What? It was high.
Should have been yes. Those little strips, if you had it on the same strip, you should have had a yes. C. Yes. D. Yes.
It didn't do nothing.
E.
No.
No. F. Yes. And what about G? Yes. Okay. Now we go to reactivity. A, did it react with either?
No.
It just floated. So no and no. B, did it react?
Yes.
With both of them?
No.
Yes.
Yeah.
Should have done something probably with
Water
both.
bubbles, little bubbles.
Yes and yes. C, that really shiny stuff?
Little
bubble.
No.
It didn't react though. It just, I don't think it did anything. So I would say no and no. D? No. No and no. E? No. What about F? It did. It should have changed color. It should have been a no here, but it should have turned red in the blue stuff.
I'm colorblind.
Okay, that's why I'm here to help. Here to help. Here for you. Last one. What happened?
And then nothing. Bubbly boy boy.
So yes and no.
Yeah. No.
So
Oh yeah.
here's what I'm going to do. What color do you want to make metals? Yellow or
Green.
green? So if it has a metallic character, I'm going to suckle it. Suck it? That's weird. Circle it. Nothing sucks, everything blows. All right, if it's green, it's metallic. Metals are malleable. Metals conduct. Metals are shiny, and metals react. So if it's green, I'm going to meet this metallic. So here we go. B, shiny. That's metal, right? Crushing, malleable. That's metal. Conductivity, yes, yes, yes. C, shiny. That's metal. Ooh, but it was brittle.
No, wait.
And it did conduct. Okay. D, it was shiny. It was malleable. And yes. E, I got nothing. F, It was malleable. It did conduct, and it reacted with one of them. G was shiny, malleable, it conducted, and it did react. Okay? Just follow along for this part. What color we want to do for nonmetals?
Red. Blue.
Let's do yellow. Here we go. Dull, brittle, no, no, no. Here, I got dull, brittle, no, no, no. And then here, I've got none, none. I've got dull, got none, and none. So, I think there's two that I can definitely identify as metals. Which two would you say are definitely metals?
B,
B and G. Okay, so on number 3 at the bottom, I would say B and G are metals. So B, actually this would be on number 3. So my metals, I've got B and I've got G so far. Those are definitely metals. Also B was, if you'd like to write it down, magnesium. Magnesium is over here on the left side of the periodic table, right? Here are my metals, here are my nonmetals, here are my metalloids. Definitely a metal. Which one of them were you saying is definitely a metal? G? G? Was that the pokey stuff?
Yeah, sure.
That was zinc. All right? That was zinc. Definitely a metal. Okay, which ones are definitely nonmetals? A is definitely a nonmetal. A was, what was A?
I don't know.
Oh, it was the black stuff. It was carbon.
Well, that hurts my head.
All right? A was carbon.
You get a new laser.
And what was E? The yellow stuff smelled like farts. Sulfur. Shh. Bring it in. So I would agree that A and E were definitely nonmetals. A and E. So we know that there has to be some kind of metalloids. All right, the ones that kind of have properties of both. Now, let's look. On C, I've got 1, 2, yes. So if I'm looking at, I've got 1, 2, 3, 4 things, right? If I'm counting reactivity. C, I have 2 out of 4. Agreed?
Yeah.
For metals. D, I have, I'm going to put this back green. D, I've got 3 out of 4. So D, I think we can probably classify as a metal.
Yeah.
Okay? That's mostly metal. So let's put D as a metal. And D, what did D look like? Those little balls?
No.
What was D?
It was I don't know, big piece.
Yeah, it was the little balls, wasn't it?
No, that was G. Was it?
No, G was the pokey things. I think D was those little balls. D was tin. Tin. That's a metal.
I'm done.
Okay, and then F, I've got, it was dull, but I had crushing, conduct, and react 3 out of 4. So I'd say that's a metal. So F is a metal. F, that wiry stuff, what was that?
I don't know.
You might use it in your dishes to wash dishes.
I don't know.
It is element number 26.
Okay.
Iron, which is steel wool. Now, the one that's exactly 2 out of 4 is my only metalloid. And that would be letter C. Letter C was silicon.
Ow.
Letter C was silicon, because notice, it's right along the what? The stairs. So that was silicon. Please put your name on the back page that you were on that page, and pass it up. That should be 100% for everybody now. Put your name on that back page, pass it up. No, on the back. on the back page we were on. I want it on this page.
Yo, can I have a glove?
No.
Put your name on it.
Why do we have so many decimals?
Pass that up. Get out your coloring. Oh, I need to pass that back, actually. Get out your colored periodic table now.
You didn't color your periodic table?
You should have. I'm going to pass your packet back. You should have the colored periodic table. Thank you. Thank you. Thank you. Did you get that copy down? I have your packet. You should have your periodic table, the one that you colored. Here is your packet. I'm going to pass this back to you.
I turned the paper in big.
There's the packet. You should have the periodic table that you colored, though. Oh, there you go. Good. All right, Sean. Caden is not here. Can you turn around? All the way. Thank you so much. Kyle, where's Kyle? Kyle.
Why did I just catch you staring at me?
Jason.
Thank you.
Adrian. Yes. It's where? If it is, we'll find it. Amity. Victoria. Brendan. Aiden.
Yes.
Liam.
Okay.
I do need that.
Where's Cookie Girl? Leah. Jazz.
What'd you get?
Hunter. Lily.
I'm good. I'm too full.
Josue.
Why can't you like bother with waiting on me?
Corbin. All right, so get out your colored periodic table that goes with this. Did you turn one in?
Yeah, right?
Yeah.
No, we know each other, dude. I know where you live. That's why you're on the table. I got your IP address.
I'm looking.
What did you review it? What did you review it? What did you review it? What did you review it?
Hey, can you guys check your papers and make sure that brownies didn't get stuck to the back of anyone's?
Section 1 thing on my periodic table.
I didn't even bring my stuff, so. Our brain.
What did you review? No talk for you.
All right.
Josh?
Yeah, I can't find my
Okay.
No.
If you can't find it, you can just fill it out as we're going through.
Whatever you do on your table.
I'm not sure where it's at. All right, here we go. Here's what we're going to do. We're going to go through this packet together, make sure you have what I have, and then also make sure that we're going to be writing some things on our periodic table. So make sure you have a writing utensil.
Dude, mine's 10.
Okay, so take a look at your periodic table. Does anybody need a new periodic table?
Why are you looking at me?
They just called you a boy.
Wait, I need one too. No. Wait, I need one. Oh, right here. Thanks, King.
All right, here we go. So here we go. Number 1 on the packet. How did Dmitry Mendeleev organize the periodic table? I said he organized them by weight and then group them together by rows and columns based on chemical and physical properties. So you should have had something like number 1 on your paper. Or you could have just said by weight and atomic numbers. Either one is fine. Number 2, what could he predict using his periodic table? New elements, undiscovered elements, right? So there were elements. We watched in a little video. Remember how the one French guy's like, this is the new element? He's like, no, you were wrong. So he could predict those new elements. Define the modern periodic law. This was directly from our notes. So I said, when arranged according to their atomic number, elements show repeating or, can you stop that? Thank you. Periodic trends in their chemical and physical properties. What's the difference between a period and a group? Notice what I did. A period is a row, what? Across, and a group is a column down. So I just drew arrows for period and down. I can zoom it just a little itty bit. I can zoom in a little bit. Any questions so far? So now we can go over this because we have now done our lab, and now we know the properties of metals, nonmetals, and metalloids. What's up? Did you turn your lab in? Okay, great. So down here, I said that metals they're reactive, usually solid. They conduct. They're malleable. Form positive ions. We're going to talk more about that in a second. They're shiny. They like to lose electrons. And if you have properties of metals, you would then probably guess that your nonmetals are the opposite. So if metals are solid, nonmetals are going to be gas. If metals are conductors, nonmetals are going to be insulators. Yes? Malleable. If metals are malleable, nonmetals are going to be brittle. If metals form positive ions, nonmetals form negative ions. If metals lose electrons, nonmetals gain electrons. If metals form positive ions, nonmetals form negative ions. So that's your metals and nonmetals. The ones in the middle, the semiconductors, our example was silicon, they have properties of both. So if I was going to make a Venn diagram, it would look like this, right? Here's my nonmetals, here's my metals, and the ones in the middle have properties of both. Wasn't that a beautiful Venn diagram?
Those are perfect circles.
Pretty much perfect. The one on the right especially.
Yeah.
I would say the one on the right is a perfect circle.
Oh.
This one on the right looks really good. This one's a little lopsided on the left.
Yeah, I love how it's all connecting too.
Yeah, the ones in the middle, properties of both. Briley.
What's the third word in the middle one?
Intermediate conductors classified as nonmetals but have properties. You can just write both, right? Semiconductors have properties of both. They have properties of both. Any questions on page number 1? Okay. Let us go to page number 2.
No, sir. I don't want to be more.
Can I like see your copy?
Yes. So here we go. Moving on. What is a valence electron? Did you say an electron that's on the outside? Yes? Why do elements in the same group? Shh. Why do elements in the same group have similar properties? Because they have the same number of valence electrons. Then it said to color the alkali metals dark blue. So you should have colored on your periodic table from lithium to francium dark blue. Not hydrogen, just these dark blue. How many valence electrons is in group 1? 1. Is it easier, because they all want to have a full outer shell, to lose 1 or gain 7? What's less? Lose 1. And if I lose 1 electron, what charge do I become? positive 1. Make sure right now you're writing +1 above group 1 on your periodic table now. Do that now. Write a +1 right here above group 1 on your periodic table. +1.
So basically, whatever group it is, that's how many.
Just stay with me. So, if these are 1 away from having a full outer shell, they're really, really what? They're really, really reactive. So if you look at the properties of alkali metals, I said they're soft, they're shiny, they react violently with water. If you toss one of these in water, they explode. If you take chemistry, you'll get to see that in person.
What grade?
I'm going to show you a movie the 2 days before Thanksgiving break where they're going to do this on the movie. It's really cool. It's also way better than the movie we just watched.
Wow.
These you will not find in nature as an element because they're so reactive. They're always binding together with something else as a chloride. So they're really reactive because they only have 1 valence electron. If they get rid of that valence electron, they are stable. That's why sodium wants to pair up with what? Chlorine. There's a reason that they're a perfect match. Question.
So if I put a battery in water, it blows up?
No, because a battery is not pure lithium. It's also a lithium ion. It has to be lithium element. Moving on. Color the alkaline metals light blue. So you should have colored group 2 light blue. Question. If it's group 2, it has 2 valence electrons. Is it easier to lose 2 or gain 6? Lose 2. And if I lose 2 electrons, what charge do I become?
Positive.
Write +2 above group 2 on your periodic table now.
I got a question.
Yes.
Where's the white one?
The white ones are man-made. They are made in a lab. You do not find those in nature. So they're elements that exist, but they are made and then they basically just disappear right away.
Goodbye.
What are the properties of the alkaline metals? Well, these, they got to lose 2 electrons. So they're still reactive, but a little bit less. They're soft, they're shiny, but less reactive than alkali earth metals. A little bit less reactive. Then you colored this middle block green. Yes?
Yes.
You colored this block green. What is different about the charges of transition metal ions? What'd you guys get for that question? What's different about the charges of the transition metal ions? Said you had to use your Chromebook. Yes, Hunter's right. They can vary their charges. Their charges are not always the same. Everything in group 1 was a what charge? A +1. Everything in group 2 was a +2. But the ones in the middle change depending on what they're matched up with. So there's a few exceptions. One of the exceptions, guys, one of the exceptions, that's iron. That's iron that's rusting. When iron rusts, it lets off heat. It's exothermic. Pretty cool. So zinc does not form multiple charges. So what I'd like you to do on your periodic table, write a +2 on zinc right now. Physically on the periodic table, write a +2 right on zinc.
Whoa.
Zinc doesn't change. Another one that doesn't change is silver. Notice it's this little corner. Silver is always a +1. So write a +1 on silver right there. Physically on it on the periodic table. What?
Why is it so loud?
It depends on the day.
Depends on the day.
Silver, you're writing a +1 physically on it. Cadmium. It's this little corner right here. Cadmium is always a +2. So write a +2 on cadmium right now. It doesn't change. That's going to matter more for next chapter. So far, you've done a +2, a +1, and a +2. +2, +1, +2. And then also aluminum. Aluminum is always a +3. So write a +3 on aluminum right now. So you should have written charges on 4 different elements.
That's P.
So that's why, shh, we skip all these. We don't write charges above these because these all change. You'll see why next chapter. That's why it goes +1, +2, and then we change it to something else there. Can I flip my page?
Yeah.
Here we go. What are the properties of the transition metals? These are less reactive. They're malleable and they're common. This is what we build stuff with. We build stuff with iron, cobalt. We have nickel in our coins. Copper is in our pipes. Mercury, gold, we wear it. Platinum. These are our more stable elements that we build stuff with. Why? They're not reactive and they're harder. Common metals, yes. So, you colored these up here, orange, the nonmetals. And then it said to color the halogens red. Did you color this column red?
Yes.
Yeah.
This column has how many valence electrons? 7. Is it easier to gain 1 or lose 7?
Lose 7.
What's less? It's easier to gain 1. And if I gain 1 electron, what charge will I become? -1. Please write a -1 above group 17 now.
Yeah. Do it now.
Oh.
Group 16, guess we're going to write above that? -2. So write a -2 above group 16. Guess we're going to write above group 15? -3. Don't write anything on 14 yet. Group 1, we have a +1. Group 2, we have a plus.
2.
Guess we're writing on group 13? +3.
I'll put them at-
Well, snap. What are we going to write above group 14? Because I've got a +3 here. I've got a -3 here.
0.
18.
7.
No, it's not.
You're going to write plus or -4. So on group 14, above it, so here's 14, I want you to write plus or -4. It can be either way. Group 14 can gain 4 or it can lose 4. It depends what it's matched up with. Okay, so then I go -3, -2, -1. We're going to talk about group 18 in a second. What are the characteristics of the halogens? They are very reactive, poisonous gases. They also have a strong smell. Why? How many valence electrons are they away from having a full outer shell? Only 1. What do they want to do with 1 electron? Gain it. What do these want to do with 1 electron? Lose it. Do you see how those are a perfect match for each other?
Yes.
Yes. That's why. That's why sodium and chlorine together, perfect match. We're going to talk about that more next chapter.
I love chemistry.
Chemistry actually is kind of cool. Kind of cool.
Just kind of.
Noble gases. How many valence electrons? I wrote. What did you guys write? 8? I would write 8 or 2. 8 or 2. Here's why. Noble gases, group 18, have a full outer shell. How many can the first shell hold? 2. How many does neon have? 2. So would that shell be full?
Yeah.
Yes. So this would be 8. So I wrote 8 or 2. If they have a full shell, do they want to lose electrons? Do they want to gain electrons? So I guess we're going to write above group 18. 0. And if you want to make it a smiley face, you can, because they're happy. They're noble. All right? They don't need anybody. They're not going to react.
I don't know, smiley.
Characteristics of the noble gases. They exist as single atoms. They don't bond because they already have a full outer shell. They're not reactive. They're gases. And they have a full outer shell. Their outer shells are full. And then you colored these along the steps purple. Where to know the properties of the semiconductors? They are both. They have properties of both. So what I said were, they're technically nonmetals, but they have at least one property of metals. They conduct heat under the right conditions. Remember silicon from our lab? Was it shiny? Yes. Really shiny. Was it brittle?
Yes.
Did it conduct?
No.
Did it react? No. So 2 properties of metals, 2 properties of non-metals. Silicon's very important in computers. What are some characteristics of silicon? I said it's a semiconductor because it does conduct. It's also the most abundant element in the earth, right? It's also hard, right? You don't want your computer chips to be like pancakes. You shove them into your computer and they like get all malleable. I love pancakes. What? So do I. I don't know why I use that example. I guess that's what my mind was thinking about, pancakes.
That sounds yummy.
Nah, you gotta bake them in the oven though.
Any questions on this?
Yeah.
We are now ready for our vocab quiz.
What?
You can have out any notes or just not your Chromebook. Remember, the vocab quiz is open notes. If you defined your vocab, put it on note cards or the notes.
No, bro, where'd they go?
But you cannot have your Chromebook open.
What do we do when we don't?
Then you have to do it. There's a word bank.
They left.
But it's just, we just have to match.
Huh?
Match.
Put the right word in the right blank.
Oh, okay, I got that.
They're not
Yes.
in here no more.
Your notes, yes. Just no Chromebook.